question 6, we have a couple of amines, and our goal is to identify which one is the most basic. In part A, we have aniline, and we have paranitroaniline. The nitro group is electron withdrawing. Because it's electron withdrawing, it's pulling electron density away from the amine. If the job of a base is to be an electron donor, remember that's our definition of a base, is an electron pair donor, the more electrons that we pull away from the amine, the less basic it's going to be. And so our aniline compound, the one without the electron withdrawing group, is the stronger base. In part B, these two amines look relatively similar, but there's a critical difference, and the difference is the compound on the right is actually pyrrole. And in fact, we talked about pyrrole in lecture, and we said with pyrrole that the lone pair on the nitrogen, or I'm sorry, the hydrogen on the nitrogen in pyrrole is actually fairly acidic because of the aromaticity of the anion. Well, in fact, pyrrole itself is aromatic, and it's because the nitrogen is donating its lone pair in with the other pi electrons to form an aromatic ring. Well, if it's doing that, it means that that lone pair is not available for nucleophilic attack or for functioning as a base. It means that for pyrrole to function as a base, pyrrole would actually have to lose aromaticity. And we've learned previously that losing aromaticity is a very destabilizing effect. The compound on the left has no aromaticity, so its nitrogen is just your typical nitrogen, and there's no loss of stability from donating the electrons. So that makes it a stronger base. And again, the reason is because it does not lose stability by donating electrons, whereas pyrrole has to break aromaticity in order to function as a base.